Okay, so I'm going to do LT5 and LT6 practice, just the ones that I've circled. You should have this out next to you at all times while writing proofs, especially on an open notes test. So the first thing we always do is read the givens. So Q is the midpoint of SN. I know that means Q is in the middle, and that gives me these two congruent segments. If you're not sure, you should be going over here and finding the midpoint. It shows you that this is exactly what it's talking about, and there's an example from the notes. So make sure you're utilizing that correctly. Okay, then I'm going to read my next given and label that. So angle 1 is congruent to angle 2. And I have no more givens, so I'm going to go back and do the vertical angles or reflexive property. I'm going to name those 3 and 4. And now I can start my proof because I know that this is going to be an angle side angle proof. Again, if I block out one of those triangles with a finger and look close, the side is in between those two angles. So my first statement is going to be Q is the midpoint. This is not nice handwriting right now because I'm holding the camera with one hand and just kind of writing with the rest. That's given. Now, anytime you have a given that's on this chart, you should have a next statement and a next reason, and that's what's here for you. So my next statement is going to be SQ, because again, that's what I labeled from it, is congruent to QN. And then again, from that chart, I'm gonna write down the reason. And it says a midpoint divides a segment into two congruent parts. Okay, I'm done with that, and that gives me my side, so I check that off. My next piece is gonna be the next given, and I like that given because it's no vocabulary, so I can just go with it. So that's gonna be my angle, and now I still have another angle. I look for my picture, that came from vertical angles, so I can put that in at any time. I don't need a given for it, and I can say vertical angles are congruent. Now that I've crossed out all 3 pieces, I know that I have made it to the end of this proof because this proof is only proving triangles congruent, and I can say triangle SQR is congruent to triangle NQM. Moving on to the next one that I circled. My given is parallel lines. So again, if you come here, this tells me that I'm looking for alternate interior angles. So I'm gonna pick C and D. E and B are also alternate interior angles. You can use both, or you can just pick one. And this is how I would start writing that in my proof if I wanted to write it as I went this time. So my second statement would be angle C is congruent to angle D. Again, that's what it tells me I get, and that's my reason. So alternate interior angles are congruent when lines are parallel. Okay, so that's done. Now I go to my next given. So A is the midpoint of CD. That was given to me. I need to now figure out what else to do. So again, I go back here. This kind of shows me an example. So when I come over here and I find CD, that tells me CA and AD are congruent. So that's my next statement. And my reason, again, comes directly from there. I'm just going to copy that into it. A midpoint divides a segment into 2 congruent parts. You will have way more space on the test, just so you know. Okay, so that's written. And now I look, I'm out of givens. I only have 2 things in my proof, meaning 2 congruent pieces. So I look to the picture, and again, I'm gonna use vertical angles. I'll put a 1 and a 2 in there. So statement 5 is angle 1 is congruent to angle 2. The reason is vertical angles are congruent. And that tells me that I can now prove the triangle's congruent, which is the goal. And if I come up here and look, remember, cover 1 if you need to. This is an angle side angle proof again. And I have done all 3, so I'm good there. So I showed you 2 different processes. It's up to you which way you want to do that. Okay, I'm gonna do F next. E is an HL proof, just to give you a heads up, so it's gonna be a little bit different than what you're used to, but I would like to explain this one first. BD bisects angle ABC. So I see I have a bisector up here and I have a bisector down there. you'll see that it looks like this example. So it's the angle bisector. So I'm looking for two angles to be congruent, and I'm going to use that reason. So I come back over here and I find angle ABC. So that tells me that those are my two congruent angles, 1 and 2. I read my next given, perpendicular lines, just like that. And that tells me I want two congruent angles, and that's going to be the reason. And I notice that I boxed them this time. It's a little bit different than before because they are not just congruent, they are also right angles. And then I have no more givens, so I'll go to reflexive property. So again, this is ASA again, and it just so happens that these are ASA proofs. So I start writing it. So number 1, my first given is BD bisects angle ABC. And from that, I wrote those. And again, I could get that over here from the chart to help me. So angle 1 is congruent to angle 2. And my reason, again, is going to come right there. Right there. And angle bisector cuts an angle into two congruent angles. Okay. And again, those symbols are all fine. So I've used that. I'll write my next given now because I've now crossed off an A. My next given is that I have BD perpendicular to AC. Given. I'm going to put a 3 and a 4 for those angles. I hadn't done that prior, so I'm doing it now. So I can say angle 3 is congruent to angle 4. Now, as a reminder, for perpendicular, you have two choices. You can say that they are congruent, or you can say that they are right angles. This, because I'm using an ASA proof, I'm going this way. So that's why I said angle 3 is congruent to angle 4, but this is my reason. Perpendicular lines make congruent right angles. So I will write that with my symbols. Perpendicular lines make, again, I'm sorry for the writing, make congruent right angles. There we go. Okay. So that's my reason. Now that would be my reason either way, but we'll talk about that when I get to the HL proof. Okay. So there's another angle. Now I need the side. That side came from reflexive property. So BD is congruent to BD, reflexive property. It's harder to write on the bottom of the page with one hand. Okay, reflexive property. And then statement 6 is triangle ADB is congruent to triangle CDB, and that's because of ASA, because I just finished all of those pieces. All right, letter E is a little bit different, and then I'm going to stop this video. I'll do LT6 in a separate video, mostly for time. So I start labeling everything. AB is congruent to DE, so I label that here and here. I read my given of the perpendicular. We just talked about that's what I'm going to label. So I have my right angles here and here. And yes, those are vertical angles, but because of this, I'm not going to use them as vertical angles. I'm going to use them as right angles. And then C is the midpoint of AE. So again, I would go to my chart, but we've done that. I think this is the 3rd time now. So I'm hoping that you understand that AE is what's getting cut in half, and those need 2 dashes. Okay. So if you covered one of those up, you'd realize it's an SSA proof. That's a no-no. Remember, SSA is not okay. That means it's HL because I have that right angle, which is important, and it's going to lead us through this proof. So I started just like anything else. The only thing that changes is I'm going to choose to use a different statement for one of these. So AB is congruent to DE. That's given. Okay. AB and DE, those are my hypotenuses. So hypotenuse, check. Okay, statement 2 is my perpendicular. Now on this chart, I showed it 2 different ways and I explained it to you in the video, but I'm going to explain it again momentarily. Okay. When you're given perpendicular, you have this option, but you also have, or say they're right angles, which I explained in this video over here, that you can say that they're right angles, but you might want to add this into your notes if you don't already have it there. And that would be if HL. Okay, so that's my next statement. I'm going to say that angle, and I'm going to label them in my picture right now so that I can call them angle 1 and angle 2. Angle 1 not is congruent to, and angle 2 are right angles. And the reason is the same as over here. It's still perpendicular lines make congruent right angles. I'm just focused on the right angle part instead of the congruent part this time. So perpendicular lines make congruent right angles. And then I can say that triangle, not that they're congruent, don't jump the gun, and triangle EDC are right triangles. That seems obvious, but you do have to say it in a proof. So right triangles have right angles. And now I've said the right angle part of this HL thing. Now I'm just left with L. And for sake of time, I'm going to say these because the bell is about to ring. And also I'm running out of space on this paper. But again, you have tons of space on the actual one. This statement should be C is the midpoint of AE given. This should be that AC is congruent to CE. And your reason should be this right here. And then your last one would be the triangles are congruent. And the reason would be HL. I will do LT6 in a separate video.